Hey guys, Mr. T here, just doing a quick video on the solutions for the 10 Extension Maths practice exam. So hopefully you'll see that this shouldn't take that long, especially if my video allows me to finish it within the time limit while explaining things to you. Okay, so let's get started on the first question. You have the same base number being multiplied with different powers, so the powers are added. So that's going to be T 7, 8, 9, 10, 11, 12. My pen is a little thick here. I'm going to make it even thinner. T to the power of 12. Now you've got a division. I'm going to remind myself that T to the 3m, anything written with no power is to the power of 1. Because it's a division, you're subtracting. So it's going to be T to the 3m take 1. You have a bracket situation here. So it's going to be a to the power of 3m multiplied by the power on the outside. So that's going to be a to the power of 12m. Okay, more complicated ones. So I'm going to remind myself that this is actually 5 to the x to the power of 5 times x to the power of 3, y to the power of 2, over 15 x to the 1, y to the 1. I can do something with the 5 and the 15 because 5 goes into 15 3 times, so it's 1 on 3. X to the 3 over x to the 1 is going to be x to the 3 take 1 is going to be x squared. Y to the 2, y to the 1, so it's going to be y to the 1. You're going to subtract. So that's not fully simplified. That 1 can disappear. Well, I don't need the power of 1 there. Over 3. Last one on this page. So combining a bunch of rules, it's going to be the power on the outside applies to all of these things. So 4 squared times by c to the 3 times by 2 times by, I don't need to write the times, and d to the 2 times by 2 over nothing happening on the bottom, but I'm going to remind myself that it's d to the power of 1. 4 squared is 16, c to the 6, d to the 4, over c to the power of 2, d to the power of 1. 16 doesn't cancel at all, but 6 take 2 is going to be 4, and 4 take 1 is going to be 3. 16, c to the 4th, d to the 3rd. So that's page 1 done. Next page. Okay, so we're going to be dealing with inversions. Well, not inversions, reciprocals. We're going to be inverting fractions here. So you have to be careful because when it's a fraction and bracketed and the power is on the outside, that power applies to the top and the bottom. My pen went thick again. The power applies to the top and the bottom separately. So 2p to the negative 3. Over 5q to the negative 2, also to the negative 3. That power is going to apply to the stuff inside the brackets separately, so 2 to the negative 3 and p to the negative 3. 5 to the negative 3 times by q to the negative 2 times by negative 3. So now let's think about the reciprocals. This is on top, but it's a reciprocal, so it's going to go on the bottom. This is on top, and it's reciprocal, so it's going to go on the bottom. This is on the bottom, but it's a reciprocal, so it's going to go on the top. So we're going to have 5 to the 3 on top, 2 to the 3 on the bottom, p to the 3 on the bottom, and q to the negative 2 times by negative 3 is to the positive 6. We can cancel this down now, or simplify it. 5 to the power of 3 is going to be 125. 2 to the power of 3 is 8. Nothing I can do with p and q, so p to the 3, q to the 6. So that is the index laws questions. Now let's go to, still trying to work out why my pen is suddenly thick, doesn't matter. Simplify or find the answer to this. They're the same surd. So if I've got 3 root 7s plus 5 root 7s, I'm going to have 8 root 7s. I have 3 root 10s. Okay, so these two aren't the same. The outside ones are the same. The inner two are the same. So 3 take 2 is going to be 1 root 10. 2 plus 5 is going to be 7 root 3. Fully simplified, root 12. Well, root 12 is the same as root 3 times by 4, which is the same as root 3 times by root 4, which is the same as root 3 times by 2, so it can be written 2 root 3. 5 root 98. So I'm not galaxy brained. I don't know what goes into 98, so I'm going to use the calculator that I'm allowed to use. So I'm going to see what goes into 98 in terms of square numbers. So 98 divided by 4 is 24.5, no good. 98 divided by 2 times 2, 9. 3 times 3 is 10.888 recurring, so that's no good. 98 divided by, it's the next square, 16. No good, 6.125. 98 divided by 25. Oh no, that's not going to work because 25 has to be ending 0 stuff, so 3.92, no good. 98 divided by 36, 2.72 recurring, no good. 98 divided by 49, which is 7 times, 98 divided by 49 is 2. So it's going to be 5 times by root 98, which is 2 times 49, which can go to root 2 times by root 49, which can go to 5 times root 2 times by 7, because the square root of 49 is 7. Order of multiplication doesn't matter. 5 times by 7 is 35, times by root 2 is 35, root 2. Find the following products of quotients and fully simplify the final answers. Well, root 3 times root 5 is going to be root 15. And that looks like it for the second page. So moving on. Okay, let's remember order of multiplication does not matter. So we can multiply the numbers out the front first. Negative 2 times by 5 times by 7 times by root 3 times by root 2 times by root 10. Negative 2 times 5 is negative 10, times 7 is negative 70. Root 3 times root 2 is root 6, times by root 10 is root 60. Now root 60 is 4 times 15, so it's going to be root 4 times 15. That's going to cancel down to root of 4 is 2, root 15. And negative 70 times by 2 is going to be negative 140, root 15. Root 10 divided by root 2. Well, that's just the same as 10 divided by 2, but with roots. So it's going to be root 10 over root 2, which is going to be root 5. 4 root 7 divided by root 7, well, you got 4 root 7 over root 7. Those two cancel out, so it's going to be 4. Expand and simplify. So you're going to be multiplying the outside factor with the two inner ones, so it's going to be 2 times by 3 root 2 plus 2 times by negative 5. That's going to equal 6 root 2 plus 2 times by negative 5 is negative 10. Plus and minus become minus. 6 root 2 take 10. Slightly more difficult one here. 3 root 7 times by root 5 plus 3 root 7 times by negative 2 root 7. 3 root 7 times by root 5 is going to be 3 root 35 plus 3 times by negative 2 is negative 6. And root 7 times root 7 is just 7. So you're going to have 3 root 35. 6 times 7 is 42, so take 42. That's it. 3 root 35, take 42. Express the following with an end of the third page. Express the following with the integer denominator. The denominator is just a third, so I times it by that third on, a bit cramped, I'll do it again. Times it by that third on itself, because root 5 on root 5 is 1, and so I'm allowed to do that, so it's going to be 2 root 5 over root 5 times root 5 is 5. That's an integer denominator. I can't cancel down at all. So we're good for page 3. So now, page 4. Nope. At the bottom of the page, I'm drawing. Hopefully you can see that I'm losing time just by stuffing around with this new version of Explain Everything. It's acting all weird. Okay, we have a complex, we have multiple terms on the bottom, so we have to multiply by the conjugate. So root 3 plus 2, I've rewritten it, but I'm going to times it by root 3, take 2 on root 3, take 2. Why am I allowed to do that? Because root 3 take 2 on root 3 take 2 is going to be 1. Why do I need to multiply by the conjugate? So it actually cancels out. So it's going to be root 5, root 3 take 2 for the top line, and then root 3 plus 2, root 3 take 2 on the bottom. Root 5 times by root 3 is root 15. Root 5 times by negative 2 is negative 2 root 5. The bottom, root 3 times root 3, I'm going to FOIL this. So firsts, outers, inners, and then lasts. It's the order I'm going to do. Root 3 times by root 3 is going to be 3. The root 3 times by negative 2 is going to be negative 2 root 3. 2 times by root 3 is going to be positive 2 root 3. And 2 times by negative 2 is going to be negative 4. So there's nothing I can do on the top. I'm going to reorder it though. I like to have the numbers at the front, so it's going to be negative 2 root 5 plus root 15 over negative 2 root 3 plus 2 root 3 cancels out. 3 take 4 is going to be negative 1. And then we don't want to have a negative denominator there, so remove the factor of negative 1 from everything, so it's going to be 2 root 5. Remove a factor of negative 1 from positive root 15, that's going to be negative root 15. Now we got logs after surds. 16 is equal to 4 squared, therefore log of base 4 of 16 is 2. 9 to the power of a half is equal to 3, therefore log of base 9 for the number 3 is going to be 1/2. Because the power that I'm raising the base number of 9 to is the power of a half, which is the square root. And the square root of 9 is the number of interest, which is 3. Moving on. Log base 2 of 32. Well, I know that 2 to the power of 5 is 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So log base 2 of 32 is equal to 5. Log in base 5 of 1, well, 5 to the 0 is 1, so log base 5 of 1 is equal to 0. We need to apply the log laws here. Both the same base, you're adding them, so the log law that you're using is that it's multiplication of the numbers of interest, so it's going to be 4 times by 9. That's going to be equal to log in base 6 of 36. The power that I raised 6 to get 36 is equal to 2. Because 6 squared is equal to 36. Another log laws question. So you have a number in front that can be made the power of the number of interest. So it's going to be log base 10 of 2 squared plus log base 10 of 25. That's going to be 2 squared, so it's going to be log base 10 of 4 plus log base 10 of 25. We can multiply those according to the log law, so it's going to be log base 10 of 4 times 25. That's going to be equal to log base 10 of 100. 4 times 25 is equal to 100. What power do I raise the base number 10 to get 100? 2. Okay, 10 times by 10 is equal to 100. So that's page 4 done. Moving on. Put my calculator away. What question are we up to now? Question 9. Simplify the following. So we've got more algebra style log questions. Doesn't change anything. So we have a multiplication. I notice here that we've got the same base, and you've got a number out the front, so it's going to be log ax to the 7 plus log in base a x squared. Now you're adding them, so the log law tells you that you can multiply those numbers of interest, so log a x to the 7 times by x to the 2. That's going to be log in base a of, well, now let's do the index laws. Same base number, timesing, so we add the powers, so log x to the 9. So, well, that could be 9 log base a of x. And while I'm doing that, I noticed that there's another way that you could literally do that. Because, so I'll do or, just to show you the different options. You've got 7 log base a x plus, that power there can go at the front, so it's 2 log a x. If I've got 7 log base a x plus 2 log base a x, I'm going to have 9 log base a x, which is the exact same answer. Multiple ways to get that. Okay, we've got this one, so that's going to be log a 4 to the power of 3, take log a 2 to the power of 5. It's a subtraction, so it's dividing. So it's going to be log a 4 to the 3 on 2 to the 5 equals log a. What is 4 to the 3? 4 times 4 is 16 times 4 is 64 over 2 to the 5, which we know from before is 32. Log a 64 divided by 32 is 2. I don't see a second option for working that out, but there might be. Log base 6, 1 over 9, plus log base 6, 1 over 4. With a log law, we're going to multiply them, so 1 over 9 times by 1 over 4. log base 6 of 1 times 1 is 1, 9 times 4 is 36. 1 over 36 is 36 to the power of negative 1. It's the reciprocal of 36, so it's going to be 36 to the negative 1. It's going to equal, that power goes out the front, so negative log 6, 36. It's as if there's a negative 1 at the front there. What is log in base 6 of 36? Well, it's 2, because 6 squared is equal to 36, so your final answer is going to be negative 2. And there you go, okay? Looks like that's the last log question. Log A 32, log A 8. What I'm noticing here is that both of these are a power of 2. Is 2 to the power of 5, which we've seen before. Log A of 8. 8 is 2 to the power of 3. The power can go at the front, 5 log A2 over 3 log A2. Log A2 cancels out, so you're going to end up with 5 on 3. If I did it any other way, I wouldn't have got rid of the log, so that is the simplest form that I can get that to. So solve for x in the following equations. Well, I can use logs here because we've got log, the base number is 2, and this is also a multiple of 2. I'm going to put log in base 2 of both of these. So I haven't changed the question. All I've done is put log base 2 on both sides. Applied it to both sides. That power can go out the front. So you've got x plus 1 log base 2 of 2 is equal to, I didn't do anything, to the right-hand side. Now, this can simplify. You've got x plus 1 times by log in base 2 of 2. The log in base 2 of 2 is 1 because 2 to the power of 1 is 2. So you've got x plus 1 on the left-hand side. Log in base 2 of 16. 2 times by 2 is 4. Times by 2 is 8. Times by 2 is 16. So that's going to be 4. X plus 1 is equal to 4. Take 1 on both sides, that's going to be 3. Log in base 2 of 8 is equal to x. And you've got log 2. 8 is 2 to the power of 3. It's equal to x. You've got the power goes out the front. 3 log base 2 of 2 is equal to x. Log in base 2 of 2 is 1, so it's 3 lots of 1 is equal to x. 3 times by 1 is equal to x, so x must be 3. Alright, that's page 5, moving on. Okay, we've got some triangle questions here. Oh, we've got a log, so I need my calculator. So straight away, all log graphs have a vertical asymptote at the y-axis, so I'm going to draw it, showing that it's not going to touch the y-axis. Also, anything to the power of 0 is 1. So there's going to be an x-intercept at 1, but we can check that anyway. So on my calculator, I'm going to go math, log base. It's log in base of 2. The value of x is 1. And that tells me 0. So the first point is going to be 1, 0. The next point, you shouldn't actually need your calculator for this, but if my number of interest is 2 and my base is 2, what power do I raise the base of 2 to get 2? It's going to be 1, but I'll check anyway. 2, number of interest 1. No, number of interest is 2 this time, sorry, my bad. I just did the number of interest is 1. This should be at 1. I've conveniently given you the scale here, so it's going to be 2, 1. So we've had nice numbers so far, but this is not going to be the case for 3. If my number of interest is 3 and my base number is 2, there's not going to be a nice power to raise 2 to achieve 3. It's going to be 1.58 to 2 decimal points, so slightly above, halfway between 1 and 2, so that's going to be 3, 1.58. This next one is once again going to be nice, because the number of interest is 4. The base number is 2 squared, but use the calculator to check anyway. 5 is going to be not nice, so math, log base. It's going to be base 2 and number of interest 5. That's going to be 2.32. 2.5, 2.32, somewhere like there. So 5, 2.32. That's my line for my logarithmic graph. Okay, and seeing as I've got time, if you were using the calculator and the log base conversion, right? So for example, this one here, you'd be doing log base 10 because that's what your calculator would support. So the number of interest in this last one is 5, and then you go log base 10 of the base, which was 2. So I'll do that on my calculator now. Log 5 divided by log 2 is 2.32, which is the same. Okay, so you do the same thing for all of these ones. You'd go log 4 over log 2, log 3 over log 2. This is if you've only got the scientific calculator. It doesn't let you assign the log base. Log 2 over log 2, log 1 over log 2. Just reminding you how to deal with the calculator that doesn't allow for setting the base, okay? I showed you both ways in class. Now I'm showing you both ways in the practice test solutions. Find the length of AB in the triangle below. So I have 2 angles and a side. I'm trying to find AB. That's not opposite any of the angles. 65 is opposite 18, but there's nothing stopping me finding this angle here because all angles in a triangle add up to 180 degrees. So 180 to take 85, take 65 degrees is going to be 180, take 85, take 65 is 30 degrees. So this is 30. And suddenly now, because I'm finding AB, I have opposites, so I can use the sine rule. So 18 over sine 65 degrees is equal to AB over sine 30 degrees. Cross multiply, so it's going to be 18 sine 30 degrees equals AB sine 65 degrees. I don't want to lose any accuracy, so I'm going to rearrange to get AB. AB is being multiplied by sine of 65, so to remove that sine 65, I divide both sides by sine 65, so it's going to be 18 sine 30 degrees over sine 65 degrees. And now I can find my answer all in one go without losing accuracy. Divided by sine 65 equals 9.93, and it's in meters. And that was to 2 decimal points. Okay. Find the size of theta in the triangle below. What do we have here? Opposite. This is going to be a sine rule question. So 6 is opposite of the 36 degrees. So 6 over sine 36 is equal to 10 over sine of the unknown angle, theta. Cross multiply. 6 sine theta is equal to 10 sine 36 degrees. I don't want to lose accuracy, so to get rid of this 6, I divide both sides by 6, so sine theta is equal to 10 sine 36 over 6. I cannot divide both sides by sine using my calculator, so I use the inverse sine. Sine to the negative 1 of 10 sine 36 degrees over 6. Calculator time. 10 sine 36 divided by 6. Sine to the negative 1 of the answer that I just got. That's 78.42 degrees. We need to check for ambiguous case. So how do we do that? Well, the angles in a triangle add up to 180 degrees. I'm going to take the angle that I think it could be, which is 78.42. I didn't indicate it was 2 decimal points. Which is going to be 101.58 degrees. So that's my other suspected or possible angle. Now to check whether it's ambiguous case, I go 101.58 plus the other known angle, plus 36 is 137.58 degrees, which is less than 180 degrees. So, therefore, 101.58 degrees for theta as well. So we've got 2 possible answers there. Okay. Now, moving on. Use the cosine rule to find the size of the largest angle in the triangle below. The largest angle is going to be across from the longest side, so it's going to be that angle there, angle ABC. Use the cosine rule to find the side of the largest angle in the triangle. So this is when you use the cosine rule because it's the included angle. So remember, cosine rule was c squared is equal to a squared plus b squared minus 2ab cos c. C squared, which is opposite the angle, is 7 squared. Calculator down. 7 squared is equal to A, doesn't matter what you make A, 4 squared, and B, 6 squared, take, as long as you're consistent, of course, take 2AB, 4, 6, cos, we'll just call it B for now, it's easier, less to write. And so we work that out, 7 squared is 49, equals 4 squared is 16, plus 36, take 2 times 4, 8, times 6, negative 48, cos B. Now you've got 16 plus 36, so you've got 49 is equal to 16 plus 36, that's going to be 52. Take 48 cos B. Take 52 from both sides, you're going to have negative 3 is equal to negative 48 cos B. Negative 48 is multiplying, so if I divide both sides by negative 48, you're going to have, I'll just write it, negative 48, that cancels. Running out of space. Let's do it up here. You're going to have 3 on 48. 48 divisible by 3. Yeah, it's 1 on 16. 1 on 16 is equal to cos B. I can't divide by cos, so I go B is equal to cos negative 1, whatever 1 on 16 is. Inverse cosine 1 over 16 gives me 86.42 degrees to 2 decimal points. Okay? That's page 6. Done. So moving on. Page 7. In the following diagram, the area of triangle ABC is 104,000 square meters. ABC, so 104,000 square meters. Find the length of AC with an appropriate formula. Well, because I'm given an area here, I should be using the sine area formula, which was area equals 1/2 AB sine C. I know the area is 104 grand. 1/2. I don't know the length of AC, but that's what I'm trying to find out doing this. So one of the sides is 520, the other is AC. So I'm going to make AC times by 520 times by sine of 30 degrees. 104,000 is equal to, well, 1/2 times AC times 520. Order of multiplication doesn't matter. Half of 520 is 260 times AC times sine 30 degrees. Sine of 30 degrees is 0.5, so that's going to halve things again. 104,000, half of 260 is 130 times AC. What's 130 doing to AC? Multiplying, so you divide both sides by 130. AC is going to be 104,000 divided by 130. We get 800 meters for AC. Find the length of AB using the cosine rule. That's convenient that it's telling you what rules to use. So AB is opposite of 30 degrees, so you've got a cosine rule situation here. There's an included angle between the two known sides. So you're going to have AB squared is equal to 800 squared plus 520 squared. Take 2 lots of 800 times by 520 cos 30 degrees. AB squared is going to be 800 squared is 640,000 plus 520. I don't know that off the top of my head. 270, 400. Take 2 times 800 times 520 is negative 832,000 cos 30 degrees. AB squared is going to be 640,000 plus 270, 400, 910, 400, take 832,000 cos 30 degrees. Do that in the calculator. so 910,400 is in my calculator. Take 832,000 cos 30 in brackets. We get 118,966.86 to 2 decimal points. Opposite of squaring is the square root, so AB is going to be the square root of the answer. 189,866.86. We've got 435.74 meters to 2 decimal points, so we know more about this triangle. Just write it there to help myself out. 435.74 meters. Find angle ABC. So we're finding this angle here. We know this side, we know that side. The angle we're trying to find is in between, so that's going to be a cosine rule situation. We know the side opposite the angle as well. So the side opposite the angle is 800, so it's going to be 800 squared is equal to the two other sides, both squared, added together, so 435.74 squared plus 520 squared. Take 2 lots of 435.74 times by 520, cos that corner is B, so I'm going to leave it at B. Ooh, this is taking a while. We've got 640 grand equals 435.74 squared, 189,869.35 plus 520 squared. I think I had it before, 270,400. Take 2 times by 435.74 times 520. Take 453,169.6 cos B. 189,869.35 plus 270,400. I'm going to show all these steps here. 460,269.35. Take 453,169.6 cos B. I want to get this by itself, so I'm going to take 460,269.35 from 640 grand. What do we have? That's 179,730.65 equals negative 453,169.6 cos B. That negative 453,169.6 cos B is multiplying, so I divide both sides by that. Negative 453,169.6, that's going to cancel. If I also do the same thing on the other side. So cos B is going to be 179 divided by negative 453,169.6 negative 0.39 to yeah, it's a long number there. I'm going to keep that. I'm just going to find what B is straight away by doing B is equal to cos negative 1, whatever the answer was, of 179,730.65 over negative 453,169.6. B is going to be second cosine of that answer, 113.37 degrees, rounded to 2 decimal points. I also need to indicate that I rounded to 2 decimal points there too, because I did. I lost accuracy at that point. 113.37 is that. Find the length of CD. Take care. So I'm putting hints in here because I want you to be successful. Take care. Diagram is not to scale, but sides BC, BD, CD links are shown with the correct links compared to each other. So what I'm trying to say here is that this is 520. It should be shorter than 740, and this should be shorter than whatever CD is. Because remember, there's that possibility of ambiguous situations when we use the sine rule. Find the length of CD. Well, CD squared is equal to, you know, those two sides. We're using cosine rule here because we just worked out what angle B is, or angle ABC is, and that's included between 740 and 520. So 740 squared plus 520 squared, take 2, 740, 520, cosine of 113.37 degrees. CD squared is equal to, so I'm going to cut some steps here because my hand is literally hurting. 547,600 is 740 squared plus 520 squared. We're going to have 818,000. Let's do this multiplication with the cosine as well. No, well, not the cosine, we'll just do the numbers. 740 times 520, negative 769,600, cosine 113.37 degrees. We can work that out. 818,000 take 769,600 cos 113.37, 113.37. We have 1123275.155. I'm not going to round that because that's what my calculator spat out at me. It's only 3 decimal points. Opposite of squaring is the square root. So second square root of the answer that I just got, it's going to be 1059.85 meters to 2 decimal points. Is that longer than 740? Yes. So we've done page 7, longest page so far. Keep moving. What do we have here? All right, sketch the following quadratics on one set of axes below, decide an appropriate scale. So you have to think about the scale that's going to fit these. So instead of drawing a scale to start off with, you might as well do the calculations you need at the start. So let's do up here. My pen is like thin again. I have no idea what is up with this thing. All right, so the x ints are going to be, so that's too thin now, so I'm going to go the next one up. X take 4, x plus 2, so they're going to be at negative 2 and 4. The axis of symmetry is going to be halfway between those two. Negative 2 to 4 is 6. So the axis of symmetry is going to be 3 away from those. 4 take 3 is 1. Negative 2 plus 3 is also 1. So the axis of symmetry is going to be at x equals 1. The vertex is going to be, well, it's going to be when x is equal to 1. So it's going to be 1 take 4, 1 plus 2. 1 take 4 is a negative 3. 1 plus 2 is 3. Negative 3 times by 3 is negative 9. And the y-intercept is when x is equal to 0. So y-int is going to be 0, take 4, 0 plus 2, negative 4 times by 2, negative 8. That's the first one. Let's draw a little wavy line here and do the second one. The x-ints are going to be at, x-intercepts are going to be at negative 3 and 5. Axis of symmetry is going to be halfway between those, so that's 8. A distance of 8 between negative 3 and 5, so it's going to be plus 4 from that. That's also going to be at x is equal to 1. The vertex is going to be when x is equal to 1, so it's going to be negative 1 take 5, 1 plus 3 equals negative 1 take 5 is negative 4, and 4. Negative of negative 4 is probably 4 times 4, 16. What else do we have? So you did the vertex. Axis, we do the axis symmetry. The y-intercept is going to be when x is equal to 0, so it's going to be negative 0 take 5, 0 plus 3 equals negative 5, 3. It's going to be at 15. So now we can decide the scale that we need. We need it to go up to at least 16, down to negative 8. So how am I going to fit that? It's going to be a bit uneven, I think. I need black. I'm going to do my axes. Why is it white? I want the border to be black. Here's my y-axis. It's not going to be even. How many do we have here? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We've got 16. I need to go from negative 8 up to 16, which is like 24. So one by one won't do. It's going to have to go 2 by 2. So what if we did negative 10, negative 8, negative 6, negative 4, negative 2. Origin's going to be there. 2, 4, 6, 8, 10, 12, 14, 16, 18. That's going to fit what I need. Horizontal line. Completely missed, but I can move that. That's quite wide. The widest I need to go is 5, negative 3, so I can do it 2 by 2. 1 per 2. 2, 3, 4, 5, 6, negative 1, negative 2, 3, negative 4, negative 5, negative 6. So I've got my axes set up here, sketch the following quadratics on one set of axes below, deciding appropriate scale, all done. So x-ints are negative 2 and 4. The axis of symmetry is that x is equal to 1. The vertex is going to be at negative 9. So my little label there is going to be in the way, so I'm going to move that. Lucky that fit, I misjudged that, so 1, negative 9. And the y-intercept is going to be at negative 8. So it's going to be the same on the other side. So that first curve is going to be something like this. Just as long as you've drawn it curvy. It's not going to be exact, obviously. First one, second one, -3 and 5. Axis of symmetry is still at x is equal to 1. The vertex is at 16. So 1, 16. And the y-intercept is going to be at 15, so halfway down. It's going to be the same there. So that curve is going to look like this. You can see the pen wiggling. It's about the overall shape. And also my pen is on glass, so it's not going to be perfect. How I answer the question, label the x, y, vertex. I only labeled the vertex and the axis of symmetry. I need to label the x-intercept, so that's going to be 5, 0. This one's going to be 4, 0. This one's going to be -2, 0. This one's going to be -3, 0. The y-intercepts being 0, -8, and 0, 15. That's answered that question. Let's move on. Observe the quadratic below. The quadratic, so the basic quadratic y is equal to x squared, can be transformed into this one by applying the correct or the following transformations. I need to circle the correct answers in bold text. Is there a reflection or no reflection? Well, a normal quadratic looks like this. So there was a reflection in the x or the y-axis. It was reflected in the x-axis. Dilation by a factor of 0, 1, 2, 3, or 4. If I dilated by a factor of 0, I'd be multiplying that by 0. There wouldn't be anything. Now, if I look at this, that is at 2, 7, 2, 9. It went down to here. So that's at 3, 3, 8. So when it went across by 1, it also went up by 1. Let's check one more. This one is at 4, 5. So it went from 9, it went down 4. So that's a normal quadratic situation. So it's not dilated by anything. It's by a factor of 1. It was horizontally translated. Well, it moved from here to there, so it went 2. Vertically, how did it go? Well, 1, 2, 3, 4, 5, 6, 7, 8. It was vertically translated by 9. Okay? State the equation of this quadratic in intercept form. So intercept form is y is equal to a, x take p, x take q. We know the intercepts are 5, 0, -1, 0. So it's going to be a x to the -1, which is +1, x take 5. Okay, we don't know what a is, so let's look at a point on it, which is the y-intercept, 0, 5. So when x is equal to 0, y is equal to 5, so it's going to be y is equal to a, 0 take, not p, 0 take, 0 plus 1, sorry, because that's what my equation is so far. 0 plus 1, 0 take 5. 5 is equal to a, 1, -5. 5 is equal to a times by -5. Times by -5. So 5 is equal to -5a. Therefore, a is equal to -1. Therefore, the equation is y is equal to -x plus 1, x take 5. Right, so page 8 is done. Page 9. So what do we have here? Question 18, sketch the following quadratics on one set of axes below, decide an appropriate scale. This is in vertex form now. So much the same as last time. Now the pen's thick again. This app updates are not very good. Because it's in vertex form, I'm told the vertex straight away, the vertex is going to be at 2, 3. The axis of symmetry is going to be at x is equal to 2. The y-intercept is when x is equal to 0, so y equals 0, take 2 squared plus 3. Y is equal to negative 2 squared plus 3 equals 4 plus 3, 7. And based on the teaching in class, you need 2 other points. So I'm just going to go one either side of the axis of symmetry. So I'm going to go y is equal to, let's go 1 below it. 1 take 2 squared plus 3. Negative 1 squared plus 3. It's going to be 4 when x was equal to 1. And y is equal to, let's do 3. 1 above 2. So 3 take 2 squared plus 3. 3 take 2 is 1. 1 squared plus 3. That's also going to be 4. The other one, vertex, is going to be at, we've got plus 3.5 here, so it's going to be negative 3.5, comma, and that's going to be negative 1. The axis of symmetry is going to be at x is equal to negative 3.5. The y-intercept is when x is equal to 0, y is equal to, no brackets, negative 0 plus 3.5 squared, take 1, equals negative, whatever 3.5 squared, not inside, take 1, 3.5 squared, got the calculator out, is 12.25. 12.25, take 1. I'm running out of space here. What do? Erase. I'm going to show the steps. Negative 12.25, take 1. Is it going to be equal to negative 13.25 for the y-intercept? And we need 2 other points. So we've got the axis of symmetry is at negative 3.5. So I'm going to do when x is equal to negative 2. So negative 2 plus 3.5 squared, take 1. Negative 2 plus 3.5 is going to be 1.5 squared, take 1. 1.5 squared, I believe that's 2.25, but I'll just check. 1.5 squared, 2.25, negative 2.25, take 1. Negative 3.25 when x is equal to negative 2. Let's go a bit further away from negative 3.5. Let's go negative 5 plus 3.5 squared, take 1. Y is equal to negative 5. Negative 1.5 squared, take 1. Y is equal to negative 1.5 squared is still going to be 2.25, take 1. Y is equal to negative 3.25. So we've got a bunch of locations to indicate. I need to decide my axes. So the furthest down that I need to go is negative 13.25. The highest up I need to go is 7. The furthest out I need to go to the left and right, well, I used negative 5 here. And to the right I went up to 3. So at least, so 6 on either side. And I need to be able to go 7 to negative 13. That's a little tricky. Let's do the axes. I'm just going to trial and error this, see if it works. I'm going to go the same. Scale as before and see if that works. I'm going to start from the most extreme. So let's go negative 14, negative 12, negative 10, negative 8, negative 6, negative 4, negative 2. Origin there, 2, 4, 6, 8, 10, 12, 14. Let's go 2, 4, 6, 8, 10, 12. Bit too much on the y-axis above, but we're going to fit the graph on here, so that's fine. I drew that accurately that time. Let's go wide again. 1, 2, 3, 4, 5, 6. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, let's draw the first one. Vertex is at 2, 3, 2, 3. I'm going to label it. Axis of symmetry is x is equal to 2. The y-intercept is when y is equal to 7. X 0, y 7, 0, 7. 2 other points when x was 1, y was 4, 1, 4. When x was 3, y was also 4, 3, 4. That's my curve. So it's a wide boy there. Okay. Second one, vertex negative 3.5, negative 1. Negative 3.5, negative 1. What have we got? Axis of symmetry at negative 3.5. X equals negative 3.5. Y-intercept is going to happen at negative 13.25. 13 there, so somewhere there. And what do we have? When x was equal to negative 2, it was negative 3.25. When x was equal to negative 5, it was also negative 3.25. I got my points there, so my curve is going to look like something like that. I need to go negative 3.5, 1, 2, 3. Do the same on this side. I haven't calculated that point, but quadrate is going to be symmetrical. So I did something symmetrical to the y-intercept there. Okay? So that is those two curves drawn. Observe the quadratic drawn below. The quadratic y is equal to x squared can be transformed into this quadratic by applying the following transformations. Circle the correct ones. Normal quadratic looks like this. So there has been a reflection, and it has been in the x-axis. Dilation by a factor of. Well, here you have 1, 2. It went down to 0, 1. It also went down to 1, negative 2. So over the course of 2 jumps to the right, it went down by 4, so it hasn't been dilated at all. It's been a factor of 1. It's the normal quadratic shape. It hasn't gotten thinner or fatter. Translating horizontally, it went to the left 1. Translating vertically, it went up by 2. State the equation of this quadratic in vertex form. Y is equal to, well, vertex form is going to be a x take h squared plus k. The vertex occurs at hk. The vertex is at 1, 2. So it's going to be y is equal to a x. Sorry, that's negative 1. So negative 1 is going to be plus 1 squared plus 2. I don't know what a is, but the y-intercept is at 0, 1. So you've got 1 is equal to a. 0 plus 1 squared plus 2. 1 is equal to a. 1 squared plus 2. 1 is equal to 1a plus 2. Opposite of adding 2 is taking 2. So you've got negative 1 is equal to 1a. Negative 1 divided by 1 is going to be negative 1. Therefore, your equation is y is equal to negative x plus 1 squared plus 2. That's page 9 done. Just double checking. No, I haven't actually drawn all the points here. I've done the axis of symmetry. I've done the vertex. Done the y-intercept. This is missing a y-intercept. 0, negative 13.25. I've done the y-intercept there. So I missed the other 2 points here. My bad. So it's going to be negative 5, negative 3.25. And this one is negative 2, negative 3.25. Those are all of the things that I've been asked to label. Moving on to page 10. The height of a cannonball t seconds after it's fired into the air is given by the quadratic function h of t is equal to negative 4t squared plus 16t plus 9 meters. Find the maximum height that is reached by the cannonball. So a is a negative number. My pen is thin again. A is negative 4, so this is going to be like this. The maximum. So the maximum of a quadratic is when it flips up like that, and that's going to happen on the axis of symmetry. So the axis of symmetry, AOS, is going to be at negative b on 2a. It's going to be negative 16 on 2 lots of negative 4. Negative 16 on negative 8 is going to be at 2. Therefore, the axis of symmetry is at x is equal to 2. That's going to allow us to work out what the height is at the maximum, because the maximum occurs when the time is 2. So height, when x is equal to 2, or the time is equal to 2, is negative 4. 2 squared plus 16 lots of 2 plus 9 equals negative 4. 2 squared is 4, plus 16 times 2 is 32, plus 9. Negative 4 times 4, negative 16 plus 32 plus 9. Negative 16 plus 32 is going to be 16 plus 9. 16 plus 9 is equal to 25 meters max height. Find how long it will take for the cannonball to fall back down to the ground. So the ground is going to be when the height is 0, so we're looking for the intercepts. Find intercepts. The x-intercepts. How do we do that? By solving the equation for the x, or in this case it's going to be t. So t, using the quadratic formula, it's going to be, well, I'll remind you of the quadratic formula, negative b plus or minus root b squared minus 4ac on 2a is equal to negative 16 plus or minus root 16 squared. Take 4 lots of negative 4 and 9 over 2 lots of negative 4. Negative 16 plus or minus 16 times 16, 256. Negative 4 times by negative 4 plus 16. What's 16 times by 16 lots of 9? 144. 2 times negative 4, negative 8. Negative 16 plus or minus 256. 256 plus 144 is 400, which is actually 20 times 20. So we're going to have negative 16 plus or minus 20 on negative 8. So we've got two possible answers here. Negative 16 plus 20 is going to be 4 on negative 8, or negative 16 take 20 is going to be negative 36 on 8. 4 on negative 8 is negative 1/2 or negative 0.5, or, sorry, negative 8, I forgot. Negative 36 divided by 8 is going to be positive 4.5. You can't have negative time, therefore 4.5 seconds to reach back to the ground. In Tasmania, Kanye is looking to diversify his income sources after recent difficulties. So he set up a reserve for breeding echidnas. The expected population of echidnas after T years is given by the population in terms of T is equal to 50 times by 1.26 to the power of T. What is the initial size of Kanye's breeding colony? Well, if you remember, if y is equal to a times by b to the power of x, a is the y-intercept, which is the starting amount. In this case, a is 50. So initial size is 50 echidnas. Find the expected colony size after 3 years. So the t, the power t, represents the amount of time. So this is just asking us to find the population when t is 3. So 50 times by 1.26 to the power of 3. 1.26 to the power of 1.26 to the power of 3 is 2.000376. Times that by 50. We're going to have 100.0188. We can't have part echidnas, therefore 100 echidnas after 3 years. Similar situation for this one. P when x is equal to 20. 50 times by 1.26 to the power of, what did I bracket that? To the power of 20. Getting a bit tired now. 1.26. Hopefully not making any mistakes. 101 times by 50. So you got 5086.05 to 2 decimal points. So 5086 echidnas. No part echidnas for Kanye, okay? From the parameters in the function, state the yearly percentage in growth of the colony. So remember back, y is equal to a times by b to the power of x. B is the multiplier. So here we had t is equal to 50 times by 1.26, the power of the time. 1.26 is 126%. Therefore, 26% growth per year. Every year it's 126% of itself, or 126% of what it was previously. So it must be growing by 26% each year. That's page 10 done. Circles. If a circle has at its center at 2, -5 and has a radius of 4 units, find the equation of the circle in center radius form. So it's going to be x take 2. Oh my lord. It's thick again. X take 2 squared plus y plus 5 squared equals the radius squared, which is 4 times by 4, 16. To find the equation of the circle in general form, so I have to expand it. So I'm going to write out what you're going to expand, or the multiplications that you're going to do. You shouldn't have to do this, but I'm just showing you. You're going to FOIL these, or if you're familiar, it's a perfect square. It's going to be x squared, -2x, outers, -2x, inners, -2x, lasts, plus 4, plus y squared, plus 5y, plus 5y, plus 25 equals 16. X squared plus y squared. How many x's do I have? -4 x's. How many y's do I have? Plus 10 y. How many constants do I have? 25 plus 4, 29 equals 16. In general form, it has to equal 0. So x squared plus y squared, take 4x plus 10y. Take 16 from both sides. 29 takes 16. Is 13. So plus 13 equals 0. Observe the circle drawn below. Find the equation of this circle in general form. So I'm going to start in center radius form. It says -4, 3. So it's going to be x plus 4 squared plus y take 3 squared equals 4. I'm not going to show the full steps now. I'm just going to expand that. X squared plus 8x plus 16 plus y squared take 6y plus 9 equals 4. X squared plus y squared plus 8x take 6y. 16 and 9 is plus 25 equals 4. Take 4 from both sides. X squared plus y squared plus 8x. Take 6y plus 21 equals nothing. Find the center and radius of the circles with equations below. This probably should have come first. Oh well, we'll have to do that next time. It'd be a better lead up to do the easy questions first. It's going to be at 5, -4 radius. Because this is the radius squared, the radius is going to be square root of 13. Find the center and radius. Okay, this is the reason why I did this. And at this point, this is in general form. I need to get it into center radius form. So, group the x terms together. Group the y terms together. Leave the constant there. Put the constant on the right-hand side. X squared plus 6x plus y squared, take 2y is equal to 6. Add half the coefficient of x and y, both squared, to both sides. So half the coefficient of x is 3. Square it, plus y, half the coefficient of negative 2 is negative 1 to both sides, plus 3 squared plus negative 1 squared. Do some working here, x squared plus 6x plus 9 plus y squared, take 2y. Negative 1 times negative 1 is 1 equals 6 plus 9 plus 1, 16. Bring that up here. This is a perfect square. That is a perfect square. It's going to be x. What do I square to make 9? What do I times by 2 to make 6? 3 squared plus y. What do I square to make 1? 1. What do I times by 2 to make negative 2? It must be negative 1 squared equals 16. So that's in center radius form now. So the center must be at negative 3, 1. Radius 16 is the radius squared. Square root of 16 is 4. Question 24. Getting a little tired now, but still well within the time limit, I think. Question 22. So that's page 11 done. Page 12, question 25. Kanye has recently moved to South Australia. Not sure why he moved to South Australia. He's moved to Aberfoyle Park as a result of his significant loss of income. Wonder how that happened. Kanye is extremely concerned about 5G signals and has noticed there's a 5G mobile tower close by. He's researched and found that this particular cell tower transmits 5G signals in a 5-kilometre radius. Kanye's house is 3.6 k's east, 3.4 kilometres north of the cell tower. Use calculations to determine whether Kanye should wear a tinfoil hat at home to protect himself from the 5G signals. A diagram would be helpful. Okay. Let's put the centre here. Let's put the tower here. Let's go 1, 2, 3, 4, 5. I'm going to draw a diagram of the situation. Negative 1, negative 2. What the heck am I doing there? Negative 3, negative 4, negative 5. You've got negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3. Didn't go far enough. Oh well. This calculation to determine where is Kanye's house. I'm going to do it in blue. 3.6 kilometres east. 3.4 kilometres north. So somewhere there. I cannot accurately draw a circle here. You wouldn't in your test anyway. So how can we deal with this? Well, we have this situation here where Kanye is 3.6 k's east. 3.4 kilometers north. So that's a right angled triangle here. We can find the hypotenuse of that. 3.6 squared plus 3.4 squared equals the hypotenuse squared. What is 3.6 squared? 3.6 squared plus 3.4 squared. 24.52 is equal to h squared. H is going to be the square root of 24.52. 4.95 to 2 decimal points. What distance is that? Kilometers. This is 4.95 kilometers. The tower has a range of 5 kilometers. So therefore, Kanye needs to wear the hat. He's within the range of the tower. Write the equation representing the boundary of the area covered by the 5G mobile tower in general form. I'm not going to do it in general form to start off with. I need center radius. If it was at grid coordinates -4 and 6, well, you're going to have x. Take -4 is +4 squared plus y. Positive, so y take 6 squared equals, the radius was 5 kilometers, the radius squared is going to be 25. Expand this, x squared plus 8x plus 16 plus y squared, take 12y plus 36 is 25. X squared plus y squared plus 8x, take 12y, 16 and 36 is 52 equals 25. I need to make it equal 0. 52 take 25 is going to be 27. So x squared plus y squared plus 8x take 12y plus 27 equals nothing. That is the equation representing the circle boundary of the tower in general form. Let's make sure I haven't done anything silly around here. That looks fine. So that is the end of the practice test, doing it live. Hopefully that helps you out, and I'll see you in the next video.